Hi everyone, in this session of STR8CHEM, we're going to look at how to construct the most plausible Lewis structure for incomplete octet molecules. We're going to try with beryllium chloride over here. So you do note beryllium. This one will be the central atom, okay, because it is going to be more electropositive. We do know that beryllium is on group 2, okay, and then your chlorine over here is in group 17, so it has 7 valence electrons. Beryllium has 2 valence electrons. So beryllium chloride, beryllium has 2 valence electrons. Chlorine atoms, they have 7 valence electrons. So times 1, you have 2, times 2 over here, you have 14. So therefore, you have 16 valence electrons total. Okay, so by doing this, you have 1 mark. So for the second step, we need to draw the Lewis dot symbol. For beryllium, you have it like this. And then for the chlorine atoms, like this. Okay, then you have 1 mark. So moving on to step 3. So when you look here, you have unpaired electron. So unpaired and unpaired, you will form a bonding pair. Unpaired and then another unpaired, you're going to form another bonding pair. So you have 2 bonding pairs. Okay, so this is what you call as the incomplete octet, even though beryllium right here does not have 8 electrons surrounding it, but it is already stable. Okay, so you have 1, 2, 3, 4. So this is what we call as the incomplete octets. They are already stable even though they haven't achieved the octet configuration. Another example is BF3. So boron, this, of course, it will be your central atom, and fluorine will be your terminal atom. The reason is because boron is more electropositive than fluorine. Fluorine over here is on group 17, so it has 7 valence electron. Boron will be it will have 3 valence electrons. It's situated in this will be in the group 13. Okay, so it has 3 valence electrons for boron. So boron has 3 valence electrons. So how do you do that? You can double check for boron. So boron, the proton number is 5, so you have 1s2 to s2 to p1. So when you look here, the valence electrons is 2s they are in 2s and 2p. So 2 plus 1 is 3 because it is in p block. So you have group 13. So you have 3 valence electron right over there. And fluorine, of course, this one is going to have 7 valence electrons. Okay. So we have BF3 just now. So you have 1 boron, 3, and 3 fluorine. So that one is 21. So you get 24 valence electrons in total. Okay, so this will give you another 1 mark. Okay, so the Lewis dot symbol for boron is this, and you have fluorine 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so you get another 1 mark for the correct Lewis dot symbol. So next step number 3, you need to draw the bonding pair, identify the unpaired electron. So you have this unpaired electron with that unpaired electron. So you're gonna form a bonding pair. This unpaired electron and that unpaired electron will be shared to form that bonding pair. Unpaired, another unpaired, you form another bonding pair. So you have 3 bonding pairs surrounding the boron atoms. That is not 8 valence electrons surrounding boron. So you have 1, 2, 3, 4, 5, 6, but this is already stable. So what do we call this phenomena over here? Again, this is also incomplete octet. Okay, even though it hasn't reached the octet configuration, but it is already stable.